Thank you for the opportunity. My name is Michael Akinla. I work for Panduit and I'm the business manager for UK, Ireland and the Nordic countries. With regards to the stand today, we are looking to showcase some of our recent deployments and developments within the AI field from a data center perspective. So we have high density cabling showcasing what GPU deployments look like from a server through to a leaf and a spine area. We also have the much needed pathways that are needed to support this fiber infrastructure overhead. We have the high density fiber structure cabling on display as well. And on the other side of the stand, we have the safety and security elements that look at how to manage short circuit protection within the data center power cable environment. Key concerns for our customers at the moment, primarily is the density of the fiber cabling, especially when you look at the AI deployments that are being run through. So there's just a huge amount of fiber cabling that's going into support these pods that are being deployed. We've reckoned and looked at it, we're seeing a factor of 8 growth in terms of the amount of fiber that's being used to support and deploy these servers, which are hosting GPU type connections within them. So fiber count is absolutely going through the roof, and we have to figure out a way as an industry of how we can go about supporting that in the best possible way. Hugely important because from an AI perspective, we're looking at, again, as said, the number of GPUs and the connections within the actual servers has gone up by a factor of 8. Now, those GPUs are running very, very high power requirements, so there's a huge amount of power being needed within the actual cabinet itself. As well as the power being needed, there's the cooling that's required to support that. So that said, because of the increase in the amount of fiber cabling, we've got to figure out a way as an industry of supporting that as we grow. And the way we've gone about doing that is talking to the industry as opposed to using point-to-point cabling. We're not seriously suggesting that they look at structuring their approach and their deployment within the actual AI fabric itself. We don't believe there is. I mean, one of the things that we've looked at across the industry, and some of the people in the lab within Panduit have done a significant amount of testing on this. The existing fiber infrastructure that's deployed today based on an OM4 platform and an OS2 platform, which is single mode, has the ability to support huge amounts of bandwidth on it. And that's ranging from 400 gig to 800 gig. We're even seeing the capabilities of managing 1.6T. So the fiber infrastructure that's in there today is very much up to the tasks. But of course, it has to be installed and managed in the right way, which is absolutely critical moving forward. By testing, by understanding, and by showcasing to people that yes, if you go for a structured approach as opposed to point-to-point, you are adding optical loss into the equation. But the key thing to remember there is your transceivers have the ability to cope with that. Because they are built to a high standard within the IEEE requirement, we've actually done testing on a range of different transceiver GPU test sets out there, and we find that they perform very adequately to the 400 and 800 gig standards for this. So what that means is that the amount of latency that's actually added into the system is negligible. We're looking at these pods being sub 50 meters. So you're probably looking at 250 nanoseconds of latency being added by adding a structured cabling approach. Now, by contrast, if you look at forward error correction, buffering, that adds also hundreds of nanoseconds to the actual topology and the latency element. So the key thing within latency is the topology of these particular pods that are being built. So when you look at the server to leaf, leaf to spine, making sure you minimize the number of hops for getting from one section to the other is the key element when deploying that particular design. It's not going to a structured cabling approach. The latency that adds is absolutely minimal. Well, for me, the key thing there is with the ×8 value in terms of the amount of fiber being deployed, we have to figure out a way as an industry of actually recording and documenting that information. And that's why a lot of people have asked us to come up with a solution that we have now, which is called RapidID. And we've gone about labeling all our patch cords, all our interconnects, all our trunks with an extra set of barcodes on both ends. what that gives our customers is the ability to actually document what's installed in their environment. And this is critical because as they expand, as they grow, as they make moves or changes, they know actually what's installed and where it is. So that documentation can be basically scanned in, it can be uploaded, it can be exported as a .csv and used to create a working database so that you know what's what and where. So that if you're looking to decommission or add, you have a view of actually what you have there installed. Don't be put off by adding extra optical connections into your infrastructure. It's not going to cause you any latency issue. We've done the testing, we've done the workup. The actual amount of latency added is minimal, and the key thing to be focusing on there is the topology. You're looking at the number of hops between server, leaf, and spine. That's where, by cutting that down, you can actually save yourself latency. So go with the structured cabling approach because you have the ability to then ensure that you have a safe, secure infrastructure deployment. You have control of the aesthetics, you have control of the administration, and it makes for good future upgrades in the future.